Hey there! We're going to look at a technique we can use to factor some polynomials that have four terms, and that technique is factoring by grouping. To factor by grouping, we're going to start by splitting these four terms into pairs, two groups of two. And we want to find the GCF, the greatest common factor in each pair. So if we start with this first pair on the top left, the greatest common factor could include numbers as well as variables. So if we look at these numbers, 3 and 4, the only common factor those share is 1. So there's not any number that we can divide those both by. But there is a variable that both of these terms have in common. They both have the variable a. We cannot factor out anything with z or c because that is not a common factor that both of those terms share. Only one term here has z and only one term here has c. Looking at the second group we have on the top right, first I notice that there is a negative in front of this group, and if there's a negative at the start of a pair of terms, we want to factor that negative out with our GCF so that we can make that first term positive. So our greatest common factor here will be a negative, and if we look at the numbers here, 21 and 28, those do share a common factor. We can divide both of those by 7, and if we look at the variables, both of these terms have a common factor, y, so we can divide by -7y. So that's the first step. We want to split this into pairs and find a common factor for each pair. After that, we're going to factor that GCF out. And when we factor something out of an expression, what that really means we're doing is we're dividing. So if we divide both of the terms on the top left by a, the coefficients will stay the same, but that a is now factored out, so we're left with 3z minus 4c. For the expression we have on the left, if we factor out -7y, now we're dividing these coefficients by -7. So -21 divided by -7 gives us +3. And when we factor out the y that was in this term originally, that moves to the outside of our parentheses here, and we're just left with 3z. If we divide the final term by -7y, +28 divided by -7 gives us -4, and when we divide by y divided by y cancels out, and we're still left with c. At this point, we want to check that what we have left over from each pair after factoring out the GCF should match. We should be dealing with the same set of terms inside each set of parentheses here. If our two groups do not match at this point, then it's possible that we're dealing with a polynomial where factoring by grouping doesn't work, or you might want to go back and check your work again, factoring out those GCFs and see if there's anything you missed that you can divide by. But since in this case, those pairs of terms do match, that allows us to rewrite this using the distributive property, which I have written down here. So in the distributive property, if we have the same thing that's being multiplied by two different things, we can rewrite that by multiplying those two terms times that common term, putting the two terms that we had outside of the parentheses together into one factor. So we're going to combine together the a minus 7y, and we'll still have that matching pair of terms, 3z minus 4c. And factoring by grouping will leave us with a pair of factors, each of which that has 2 terms, after we started with our original polynomial that had 4 terms. Let's look at another example factoring this 4-term polynomial using grouping. So we want to start by separating these 4 terms into 2 pairs and finding the common factor from each pair. Looking at the coefficients on the top left, there is a common factor that we can divide by. We can divide 28 and 4 both by the number 4. And there's a common variable that both of these terms have, a, so we can divide by 4a. In our second group, we have a negative, so our GCF is going to be negative. Looking at the coefficients, 49 and 7 are both divisible by 7, so our GCF will include negative 7, as well as the common variable here, which is k. Our next step is to divide each pair by the GCF that we just found. So if we start with this group on the left, dividing 28 by 4 gives us 7. And since we've divided by a, that a is no longer inside our parentheses, but we still have 7b. From the second term in that pair, if we divide negative 4a by positive 4a, well, anything divided by itself equals 1, and a negative divided by a positive is negative, so we're left with negative 1. Now we're going to divide our second pair by the common factor negative 7k. When we divide negative 49 by negative 7, we get positive 7, and our k's cancel out in this case, so we're just left with 7b. And from our last term, positive 7k divided by negative 7k, that gives us negative 1. This is the point where we want to check and see that what we have left over from each group should match after we've factored out that GCF. And since those do match, we can regroup this together using the distributive property. We'll put our 2 terms 4a minus 7k into one factor, all being multiplied by the other matching factor, 7b minus 1.